You know, in our world today, seeing isn't always believing. So today, we're going to dive into a pretty cool high-tech detective story. It's all about the battle between these super sophisticated image forgers and the AI that's being built to catch them right in the act.
But before we get into all the crazy tech that spots these fakes, let's just start with a quick challenge, just to see how tricky this can really get.
All right, take a look at these two pictures. On the left, you've got a dog, just chilling in a living room. And on the right, a tiger, in that exact same spot. Now, your gut is probably screaming that the tiger is the fake one, right? But the real question is, how would you actually prove it, especially if the edit was way more subtle in this?
And that's really the heart of the problem. Modern image editing software is just so powerful that creating these incredibly convincing fakes is getting easier all the time. And this isn't just about making funny memes. It has really serious consequences, everything from spreading misinformation to straight-up fraud.
For years, digital forensic experts have had their own toolkit for spotting forgeries. They'd hunt for these little telltale signs that editors would leave behind. But as the fakes keep getting better, the old methods, well, they're starting to fall behind.
This slide breaks it down perfectly. You've got two main paths. On one side, you have the traditional methods. Think of that like a detective dusting for fingerprints at a crime scene. And on the other side, you've got the new school approach, deep learning methods, which is more like teaching a detective to actually think like the criminal.
So these traditional methods, like something called error-level analysis, were actually pretty clever. They worked by finding tiny inconsistencies that are left behind when an image is saved and compressed, almost like digital fingerprints. The problem is, modern editing tools are so sophisticated now, they can just cover their tracks, completely fooling these older techniques.
Since those old methods just can't keep up anymore, we need a new kind of detective. And this is exactly where artificial intelligence steps into the picture.
We're talking about a specific tool called a convolutional neural network, or a CNN for short. Now, the easiest way to think about a CNN is as a really powerful digital eye. It's an AI model built specifically to see and analyze images, and it learns to spot patterns and clues that are totally invisible to you and me. So, how in the world do you teach this digital eye to become a top-notch forgery detector? Well, like anything, it all comes down to the training.
The researchers behind this model used a huge library of images called the Cassia Image Tampering Dataset. You can think of it as this giant photo album, just stuffed with thousands of authentic pictures and thousands of expertly faked ones. It's basically a massive curriculum for the AI to study.
And that training data was split into two very clear categories, authentic and tampered. The AI was just shown thousands and thousands of examples of both, over and over again, letting it learn the super subtle characteristics that give a forgery away. But before the AI can even start analyzing, the evidence has to be prepped. So, every single image is resized to a standard 128 by 128 pixels. Then, all the pixel values are adjusted for consistency, and any digital noise is cleaned up. This just makes sure the AI is comparing apples to apples and can focus only on the signs of tampering. Okay, I know this looks complicated, but think of it like the AI's assembly line for analysis. An image goes in one end. These convolutional layers are like a team of specialists, each one looking for a very specific clue, a weird shadow, an unnatural edge, a strange texture. Then the max pooling layers gather the most important findings from those specialists. It all gets funneled down until the AI makes a final, simple decision, authentic or tampered.
All right, so after all of that really rigorous training and analysis, here's the big question. How did our AI detective actually do when it was faced with a brand new set of images it had never, ever seen before?
The answer was just astonishing. After only a few rounds of training, the model's accuracy on new, unseen data, what they call validation accuracy, hit an incredible 100%.
And this graph shows that result beautifully. Each step along the bottom is called an epoch. That's just one full round of training for the AI. Now look at that orange line, validation. That's the AI's test score on new data. See how it just rockets up to 1.0, which is 100% accuracy, and then just stays there? That's some incredibly fast and effective learning.
To put it in real numbers from the final test, it was given 45 authentic images and 64 tampered images. And it got every single one right, a completely flawless performance.
This chart here, it's called a confusion matrix, and it's basically the final proof. The numbers on the diagonal, those are all the correct calls.
And the zeros in the other boxes, that means there were 0 mistakes. No real images were flagged as fake, and not a single fake slipped through as real.
Now, a perfect score in a lab is one thing, but this is about so much more than just a successful experiment. This has huge implications for how we even establish trust in the digital world.
So where could this digital detective actually be put to work? I mean, just think about it. Verifying evidence in legal cases, making sure photos and news reports are authentic, fighting fake profiles on social media, even stopping fraud and insurance claims that are based on doctored photos. The applications for this are absolutely everywhere.
So really, the big takeaway here is that as our world gets more and more digital, AI-powered tools like this one are no longer just a cool idea. They're becoming an essential tool for just maintaining a baseline of truth in the stuff we see every single day.
And that kind of brings us to a final thought. This technology, it's a massive leap forward, no doubt. But it also raises this really fascinating question. Are we just seeing the start of a brand new high-tech cat-and-mouse game where AI forgers and AI detectors are just locked in this constant race to outsmart each other? It's definitely something to think about.